how can I maximally help the people that I'm teaching, right? Because I'm not a great believer in traditional education. And Qlab emerged, which is my little organization, if you don't know what Qlab is, um, to maximally help the people who are involved in Qlab. Okay, so to understand what their dreams and goals are and to help them to the extent that I can help them. So that's about technical skills, that's about achieving their career dreams and all those kinds of things. And so just before I call Liam in to give you a concrete case study of this, I just want to say like what the philosophy of Qlab was, because this will lead into what we were talking about with the project-based learning. So I've done personal projects for as long as I can remember. I don't even remember being a person who didn't do personal projects. I've been doing them my entire life. Um, and a lot of what I did with personal projects, I sort of took on increasingly difficult challenges, and I took on many challenges which I thought I wouldn't be able to do, like getting into computer games, like doing AI research and things like this. Um, and I learned a lot in that process, and I learned how to develop skills and capabilities very rapidly. And one of the things that I experienced was when I went into computer games, everyone, literally everyone I knew in games had massively more programming experience than I did. And and I was basically an underdog. And so with a sort of negative environment with negative feedback, that kind of forced me to do massively more programming. Even though I had done some programming as a hobby, it really created the fire to do that. And then I sort of really embraced that, and I continued to do it. And I realized through this like external pressure that there was a better way of learning stuff. Okay. And so the idea of QLab is that normal education is like you learn things in steps, like small, easily accessible steps. You don't take on a step if you don't think you can make it, and you make that decision at the beginning before you take the step. You usually learn in the order in which things were discovered. So you start with old things and then go to newer things. And also, everything you do is not real. It's not to help a person. It's not a real project. It's not like actual research or anything like that. Even when you go and work for a company, your ability to do something innovative or new is like it takes years and years before anyone will let you do that. Mostly, you're basically doing a job that they are confident that you can do, given that you have no experience, right? That's the way things are structured. Now, my claim to you is that you will learn 10, 100, 1,000 times faster, beyond 1,000 times, because you will learn things that would be otherwise impossible for you to learn if you followed the traditional route by not doing that. So the idea of QLab was like, well, what happens if you take someone, and in some cases we've taken people with no programming experience, but that's very difficult. It's ideally you have some programming foundation, and we say, well, why don't you just do the highest status thing you could possibly do? Like, what is the most thing that if somebody did it, people would go, oh, that's an amazing thing that you've done. That's a major achievement in the world. And basically, we will try to get someone to do that task immediately, like in first year. So at a bare minimum, QLab projects are like doing a final year project at the end of your degree, but straight away. But in many cases, it's much more than that, because what we want is not just a regular final year project, but like a top of the year final year project, something that might be publishable research or be the credible foundations for an entrepreneurship business, something like that immediately, right? And then the purpose of QLab is to create a supervision mentorship relationship that enables you to deal with all the psychology and the practicality of doing that, as well as providing you with a very good start. So a project idea that is very likely for that to work out to some extent. And then we have this way of working where even if the original idea doesn't work out, you're still going to gain a huge amount from doing it. Okay. So before I like become more specific about that, I would be great if Liam is about. I will pass over to him to talk a
Yes.
little bit about his experiences if you're happy to do that.
Yeah, yeah. Sure.
Disappear.
If my camera would turn on. Sorry, I'm just trying to get my camera on, but it's not turning on. Hold on. Oh, I know why. Sorry. God damn it. Okay, my camera doesn't seem to be going on for some reason, but that's okay.
No worries.
So yes, I guess I'll just give a bit of background about projects we've done together and how things have gone, I guess. So yeah, I started Qlab in first year. So I was in first year. I started first year just before COVID. So like our first year exams were online, which is a bit crazy, I think. Um, so yeah, it was COVID, and I thought, I might as well do something useful with my time. So I messaged John and got a project over the summer. And kind of as John described, it was, I was definitely out of my depth in the first, the first thing I did. So I hadn't actually programmed before. I programmed very briefly before I went to university, but I'm from Donegal, so we don't study computer science for A level or anything. So yeah, I was kind of new to my year as a programmer, I guess. So a lot of other people had a hell of a lot more experience than I did. Um, so yeah, we did a project in summer, and it was on AI stuff. We did a couple together, but I think one of the first ones was like um, get look at AlphaGo, which for people who don't know is like one of the big breakthroughs in AI for reinforcement learning, and just read the paper and basically, figure out what the hell's going on. Which at the time was like literally you know, the most high status thing, I guess, as John was saying. So to get a first year to do it is kind of crazy. But yeah, that went well, and I didn't know what I was doing for months at a time. But yeah, I kind of met with John often enough, and then things slowly start to make sense. So I definitely learned a lot more than if I had just, read the textbooks on reinforcement learning or something, or, did a sort of ground up approach. So yeah, the kind of top down approach that we tend to do, I find works really, really well. So yeah, I did Qlab projects right up till final year. In fact, I guess I'm still technically doing some. So I didn't just do it over the summer. I did it while I was studying as well, and for most of placement as well. So yes, in end of second year, placement is coming up. So I did computer science as well, obviously. Um, Placement was coming up, and so I applied to Kainos as an AI engineer and was lucky enough to get that interview and got the job. Partly because I think Qlab played a massive part in that. There's not many people who go for placement with an AI role that have at least some practical experience doing this stuff. So all of you guys in here are ahead of that as well. It's a great idea for the society. But yes, so I worked in Kainos as an AI engineer, and that went, I really loved it, and I was lucky enough to work with some great people. And then I went back and did my final year, and of course, John was my supervisor for my dissertation, and so we did another AI project, um, which ended up going well. Then at the end of the dissertation, kind of near the end, John kind of suggested, why don't you enter the student and SU Enterprise Dragon's Den competition using your dissertation? So it was kind of a time where it was, it was stressful to be at the end of the year and then have this suggested. But I was like, okay, you know what, I'll try it out. And worst that happens is I don't get through to the competition. So for those of you who don't know, it's SU Enterprise run like a Dragon's Den competition where you kind of fill out an application with some sort of business idea, and then you do like pitches to judges and stuff. So I did that, ended up getting to the final with it. I didn't win, but I came like third or something, and I got like 100 quid, which wasn't bad. I mean, when I expected nothing else. Um, and it turns out I really like doing that. Um, my family own a coffee shop in Donegal, so I guess I had some experience with um, being around a business, I suppose. But I never really thought of starting one myself. So yeah, I just kind of like the experience. And then I applied to some other competitions that the SU Enterprise promoted, one of which was the Quest program. So that's another sort of entrepreneur accelerator thing. So they pay you like literally like 10 grand, I think it was, and you spend your summer basically doing like customer research and stuff. So yeah, long story short, I guess I did a lot of business stuff, and that was all motivated by kind of jumping into the deep end, both in terms of the technical projects themselves and in terms of like, who am I to go up and pitch in front of a room for money. So yeah, it's definitely getting over that fear of what the hell am I doing. So yeah, all the business stuff went well, and I started to do help out with some projects with John. So we do some innovation vouchers, which are basically like industry projects for people. So that was like a little taste of some consultancy work with real companies. So yeah, I enjoyed that, and I'm still doing that today. Um, Lots of other stuff happened in between. So I went to Berlin with some people from SU Enterprise. I met lots of friends who I meet with, regularly, who all have their own business, some technical, some non-technical, doing all sorts of stuff. And yeah, now I basically have a consultancy business. So I graduated like 2 years ago, I think, which is insane. But yeah, I've been working 2 years full time, doing sort of consultancy stuff, really. Um, I should mention as well, when I graduated, I guess that one of the main points of the story was after Dragon's Den, John kind of said to me, would you ever think of us doing this full time? And there was a grant at the time, which I think is still going, called From Student to First Sale from Invest in I, and they give you £15,000 once you hit kind of these goals they set. Yeah, and I remember John, we were like walking out of the computer science building or something after I submitted my dissertation. And you're like, yeah, would you ever do this? And at the time, I had an offer from Knos, so to go back as a graduate. So it was kind of a slightly crazy thing to do, but basically when I'd listened to John in the past, things have always went well. So I was like, all right, well, I'll try it. Worst case scenario, I just it doesn't work out and I go and work for Knos. But yeah, thankfully it has worked out, which is great so far, anyways. So yes, I've been doing consultancy work, mostly AI stuff for different companies. And yeah, learned lots of different skills that I definitely wouldn't have learned if I had to kind of um, climb the ladder in a regular company, I suppose. So you know, you're automatically working with people who have a lot more control over the business, rather than kind of working with um, people down the chain. So yeah, it's definitely very different. Um, but yes, I can't think of anything else. What do you think, John? For my ramble?
I think
Yeah,
that's wonderful. Thank you, Liam. Thank you. I'm very grateful for your
yeah, no,
story there. That was good. Yeah, yeah. Liam is probably furthest along of any Qlaber in terms of like I guess the philosophy that Qlab is based on and his significant success. So you didn't mention a few things like the 30 under 30 in the Belfast Telegraph,
Oh
and
yeah.
was it like going to Spain to advise them on AI and stuff?
Yeah, there was a conference in Spain, and I got invited with some people from Donegal to like it's kind of strange. It's like to advise them on their AI policy or something at a conference. I was like, okay, well, yeah, it's kind of crazy. And they had like translators, so everyone there must have been like two or three hundred, well, 300 or 400 people in this room in Spain, and yeah, we had a translator, and they all had earphones and stuff, and they were getting it real time translated to Spanish. And I was like, okay, what? They put me in a nice hotel and stuff. I was like, right, this is crazy. So yeah, very very lucky for all that stuff, definitely. And yeah, I have to thank John, obviously, for a lot of that
It's
stuff.
quite all right. It's quite all right. So yeah. Liam is helping me with my startup as well. So that's it's great. It's going great. Okay. Thank you, Liam. I'm going to start rambling again,
Oh
and
yeah.
if that's cool. So okie doke. So that's a little case study. I always like. I think real examples are a lot more convincing than my stories. So yeah, Liam's obviously extremely successful, and as are many Qlabbers. Um, so stepping back now and thinking about the projects. So what's in it for you? Like, why are you doing the project? Is something to think about. One of the things that I think about a lot is how to maximize what you're going to gain from what you do. So what people are typically comfortable doing is something like a tutorial. So you search online, you see somebody else has done something, and you think, oh, it'd be cool if I could do something like that. And it seems low risk because they've done it before. And in the case of a tutorial, people have varying levels of confidence about how much they can problem solve and work out how to do something, but they tend to pick extremely conservative things. Now, the problem with doing that is once you achieve that tutorial, you don't get a lot of credit for it. You get a bit of credit for it for like the initiative of teaching and things, but like people on social media probably don't care, right? If you post and you basically said, this tutorial this other person wrote, I followed it and it worked. They're like, oh, great. Like, right? What did you have for dinner? So it's that kind of level of excitement, right? So what we try to do with the Qlab projects is make it so even if the projects don't progress in any significant way, there's still quite a bit of self-promotion that can be done. Okay, great. So yeah, there's a lot of self-promotion that can be done. So what we want is even the idea itself is potentially a good thing. So Qlab projects are designed to be such that, were you to achieve what the project is about, it would have a massive impact, right? And so they're very, very kind of ambitious, visionary kind of goals. And some people find that motivating, some people might not, but it does give you something to talk about even at the very beginning, which is good. Um, what we try to do is structure it so that you can sort of mine the project for like social media posts. At least that's the way I try to do it these days. So you can work on something for a while, and I'll be constantly thinking like, how can you turn that into like a LinkedIn post or we usually use GitHub Pages because it's a way to have free web page hosting and stuff like that. And then when you're working on a project, one of the things that I found with experience is that the original idea of any project usually doesn't last. It's quite a rare person who can pick a project, make it, and share it with people. And what was originally thought to be good ends up being the thing that everyone uses. Usually, what happens is as you build something, you will solve some problems along the way, smaller parts of the project, and those are the things that are super useful. Because as you're doing the project, you will encounter problems that you didn't know existed, but they're clear problems with clear solutions. You can build a solution for it, and that'll be something that other people will find very helpful. Okay, so that's another thing to bear in mind. You don't want to like overemphasize the importance of ideas or care too much about what where you thought you would go at the beginning. It's just like, am I gaining pragmatically as the project is developing? Because like who knows, you'll run out of time, all kinds of different problems can occur and things like that. So you got to make sure you're getting something out of it as you go. Okay. Now, ultimately, what is always at the back of my head is thinking, how can we steer a project to maximum impact? And by maximum impact, I mean maximum impact to you doing the project. So a big impact would be something obviously like Liam's situation, where you start with a project and then the project could become something that wins you money from an entrepreneurial competitions or enters you into that world, and then ultimately it might lead to an actual startup that's yours, right? Another route is also to do things that have a research potential to them, so that if you wanted to, you could maybe go and get a PhD on the basis of what you were doing, right? So those are kind of like high impact outcomes. And then there's plenty of stuff in the middle, like Liam was talking about with the Kainos placement, where because you're doing very ambitious work and you're like mining it for stories effectively with the social media posts, you are you can directly benefit from that in a more conventional career. Okay, so yeah, those are the kind of principles of the projects, right? And now what I'm going to do is just talk reasonably high level about types of projects that I think about. Now, the reality is what happens if you want to be involved in Qlab is you basically arrange a meeting with me and like an hour on Teams or something, and I will, I will like I will try to like decipher what it is you really want. And I'm not perfect at this, but I have a go, right? And I have thousands and thousands of project ideas. And I just sort of like suggest things to you, talk about QLab projects that other people are doing, and get vibes from you to try to work out what it is that you want and try to align some kind of clearly out of your depth, ambitious, no background, no previous background project with you, so that it is kind of reasonably well aligned with you. And it doesn't always work. It's like it's not always a perfect match. But the thing is, all I'm trying to do is create momentum. Um, the exact project, exactly where the project goes, things like that aren't too important. I'm still concerned with those long-term objectives, steering you from where you currently are into a better situation. But we're just trying to get started with something. Okay, so these are some ideas of projects. Now, I'm actually going to talk about some projects that I've done in the past that have benefited me, as well as the kinds of projects I tend to run, just so that you have a more honest and complete, um, a more honest and complete sense of what it's like. I always like to give the unvarnished truth as whenever I can. Okay, so one of the things that is not the kind of project that I typically run in Qlab, because it's not so easy to like turn into a startup or something like that. And in fact, it can easily like go in the wrong direction, because it's almost a philosophical kind of project. And this is what I would call a first principles project. Now, while it's not a project that I tend to run in Qlab, it is the kind of project that I tend to do personally and have personally benefited from. So, I thought I would stick this in here as well. So, one of the things that I've found to be useful is whenever you want to learn something like AI, um, I tend to take something like it and then I'll go, okay, I will get a basic example working. And what I'm very interested in is what are the traditional assumptions of the thing, right? And machine learning is filled with this. So modern AI is just a variation on a more general field called machine learning. Um, and I talked about it last week about this idea that most of machine learning can be turned into like learning a function. And you can think of it as like dots in space that had different colors. And you're trying, what the AI is doing, each of those dots is training samples. And then the AI is just trying to guess the space between the dots, like what color it should be effectively. That's a kind of like crude simplification of what AI is doing most of the time. So what I find useful is to go, okay, right, well, these days I sit down with Gemini mostly. I find Gemini to be the best AI for uh, mathsy, sciencey, theoretical conversations about things. And I'll say like, okay, explain to me how does the neural network for like stable diffusion, AI art, what does that look like? Explain that to me. Or explain something a little simpler than that. Maybe, another form of learning algorithm that's more common on something like tabular data. Okay, like there's something called random forests that's widely used. It's like just explain how that works to me in plain English. I never tolerate the AI using jargon or using mathematical expressions. I'm like, I want a fully intuitive understanding of what this is doing and why it works. So I have this kind of chat with the AI about it. And then I usually work with the AI to create, a simplified bit of software that represents it. So you can get a modern AI, and these days what I tend to do is get it in an HTML page. So I don't even have to use fancy IDEs. I can just get Gemini or ChatGPT to write inside the browser a single page with JavaScript embedded in it, and it's got a UI and everything. And usually it can actually run those in the page. So if it's got any errors, it can detect that, and then you can just say like fix the errors and it'll just work quite efficiently. So I just create a single page HTML file that I can save to disk and open in Chrome, and that's something that I can play about with. It's like a minimal prototyping environment. And you can get the AI to very quickly create something that represents the core elements of machine learning with something like that, which I did recently. And then what I want to do is I basically want to challenge the way it's normally done, right? So what I want to do is not learn how something is done, like I'm going to follow this ritualistic practice that other people do. I'm not going to learn about somebody else's library. I want to learn about, like, intuitively, why is it the way it is? Like, does it have to be that way? And what I'm always drawn to in everything that I do is what I call the unquestioned assumptions. So, what is the thing that everybody assumes is an essential part of the way something works, but doesn't need to be, or it could be different? So, for example, the thing I was doing recently with machine learning, um, I focused on tables of data, like Excel spreadsheet style data. The reason for that is you want something that runs really quickly, and you can, if it's something like tabular data, it can run in a browser web page with no extra resources, right? It's not like you're doing video generation or something crazy like that. And so you can play about with stuff really quickly and easily and get feedback instantaneously, and it's kind of good to do that. So I just was learning, sticking to the very simplest case of I've got an X and I've got a Y and I'm trying to learn some values. Okay. Um, I realize I'm definitely going to run over time, by the way, guys. So, like, apologies if you have to go at the end of the hour. So, but I'll keep going, and then if necessary, we'll just talk more about these things next week. Okay. So anyway, I pick something, runs fast, I can prototype and things like that. And I'm just sitting there and I'm going, okay, like the AI will talk very confidently, like this is being done this way and this is the way to do it and stuff like that. So you have to be a bit of a like flat earther, I find. You have to be someone who goes like, yeah, but why is it like that? Like, why does it have to be like that? Which bits of the, which are really. So one of the things that I realized was normal machine learning has a set of assumptions in it, which are often not stated out loud. Modern machine learning algorithms. So one of the assumptions is that every row in the table, they assume that you have some kind of function you're learning effectively, that how to do the blurring, right? And you've got your sample points. And they assume that the sample points might have some noise in them. And noise really just represents some other influence on the number that you don't have information about. So it's kind of like if you were measuring something in an experiment, like how hot something was, and you were doing something controlled to adjust the temperature, but there was some other factor, like whether a window was open or something, and you didn't have any measurements about that, and so it's going to make your number like fuzzy all over the place. So, right. Now that assumption, um, whenever you do a normal machine learning models, they are independent, identically distributed sample points. And you'll just hear these little mousy phrases, and it's just like, oh, mostly they're not even mentioned. But if you're really asking the AI, they'll talk about it. You go, well, what does that mean? Right? Well, that means that like the error or the distribution that you're learning, like the math function, doesn't change over time, right? You set the heater at a certain value, it creates a certain temperature, and that's always the same. That's always working the same way, right? Um, so that's frequently wrong. The other one is identically distributed, right? So, or independent, right? That's the independent one. So that means that like, if the machine that you were using itself heated up and that created an effect over time, that would break that method you were using for learning. The other one is that the noise levels are about the same in each of the things. So I'm going into way too much detail, I realize, and I'm just talking about this very specific task. But what I'm trying to show you is there are a bunch of things that people do, and a lot of innovation can come from just breaking the rules of the way other people are doing it. And we live in an amazing time where you can break the rules and then you can talk to an AI who is fantastically good at mathematics and programming. And by talking to the AI, you can develop a different way of doing something and you can do experiments with it. So as you sort of mess about with the normal way of doing things, not only do you deeply understand the standard way of doing things, but you also see where the aspects of the way people have done stuff before, which of those aspects are really important and which of those aspects are just like ritual that happen to be like the first way they did it. Because most people are mimics, basically. Whenever they go to do something, it's like the tutorial example, and they follow somebody else's recipe and they repeat it, but because they've never like pushed at the edges of how it works, they don't really intuitively understand why it's working and what can be changed. And if it's not working, what's the right strategy that might get you towards a good result? Okay. So that was quite a lot of information about what I think of as being like the heart of innovation. Now, what I mostly do for Qlab is that I spend all my time doing that, breaking the boundaries of things. And then when I find some boundary that I think can be broken, I typically don't just go and do a big project in that area. What I do instead is I add it to my big list of ideas. So whenever I'm talking to somebody about a Qlab project, I'm suggesting something where I already know there's there's some gold in them there hills, right? Like there's some promising direction to go in. And I know that the majority of people are not going in that direction. So you're much more likely to produce something that when you talk about it, somebody doesn't go, oh yeah, that's like Jeff's thing, right? which you don't want to happen. um, so yeah, um, that's a very there's like a non-standard QLab project, but it's just a sort of insight into what I do. A much more common QLab project is what I would call like an integrate libraries project. So this is where you basically take two reasonably state-of-the-art things and you plug them together, and they're not normally put together. And this is one of the easier things to do. You spend a lot more of your time like debugging, getting other people's code running. And with Qlab, a lot of the time we'll be getting like research code running. So it'll be like some Python project that's a little bit tricky to run that you probably need an NVIDIA graphics card for, or something like that. And we try to plug the two together, and effectively you get like double, more than double the effect, right? Using one bit of research that people probably don't know about and is cool creates a certain amount of coolness. Using two is like double the coolness. And then when you integrate them together in an original way, you create a more special thing. So to give you an example of that kind of project, one project that some people are working on at the moment and some people worked on before is trying to create computer vision training data. So this is where you use AI art techniques. So this project involved actually 3 bits of coolness. So the first bit of coolness was we used 3D rendering in the browser, which is very cool, but actually quite not too hard to get running because a lot of AI companies are using 3D in a browser, 3JS library, as a way of proving how clever their programming systems are. So the AIs are quite good at 3JS projects. And so we created a sort of 3D content, crude 3D content, and then we used AI art to make it photorealistic. And then we used that image as training data for a computer vision algorithm. So if you wanted to create a system that could recognize cans of Coke like this, then you could have a system that would render out a cylinder somewhere on the screen from a particular angle. Maybe you could light it in the 3D environment or something. Then you pass that through AI art, and then you get a photorealistic can of Coke, but in a controllable way. And then you can create like thousands and thousands of those images with lots of different lighting conditions and camera positions and stuff like that. And then you can take all of those, and then you know exactly where in the image the object is because it's based on a 3D model that you've put in the right place. And then you can use that as training data for computer vision. So that's like 3 very cool libraries. Even if you just use one of them, most people will be quite impressed. You put all 3 together and suddenly you're like this amazing genius, right? But effectively, you're piecing together existing things to do a new cool thing. And that's a great way to create like a flashy project relatively quickly and easily, right? Um, so in those kinds of projects, one of the things that I'd be emphasizing, so if you think of the first kind of project, it's teaching you about deeply understanding why things work the way they do. Um, and and also starting to learn that kind of creative, innovative mindset that challenges conventions, right? The second kind of project, is a great high impact project in that, it's like eating a dessert or something like that, chocolate or something. It's kind of very exciting, very quickly, with not necessarily huge amounts of work. Um, but one of the things that I would emphasize in that situation is trying to do what I was talking about last week, which is AI projects which are experimentally driven. So what you would be doing is saying, well, one of the first things we want to do is we want to measure whether or not our way of doing something is actually effective or not. Um, and the great thing about that particular project that I was talking about is that it's synthetic data generation. So because you are making artificial examples of photographs in the real world, you know exactly what the correct answer is. So you have no problem with the amount of data that you have. You can generate millions of images if you have the time or the money to do so. And you know exactly what the correct answer is because you built it in such a way that you know that. And so what you can do is you can build a pipeline with existing technology. You can then measure the results because you know the correct answer. And then you can do a kind of search over the parameters or the way in which the different libraries work. Anything that you can adjust in the library, you're there, that's up for grabs. And effectively your project becomes like, how can you sort of automatically optimize all those settings to get the best possible result? And what you find over and over and over again is that clever people do cool projects that show great potential, but put very little effort into polish, basically. And so if you just polish like crazy, which is in this case, you're automating the polish through a controlled experiment and some kind of like algorithmic search over parameters, you are doing what other people don't do. Like a lot of very clever people do very clever projects. As soon as the cleverness of the idea goes away and the work becomes a bit repetitive, they stop working on the project, right? Which means there's all of this wonderful world of potential that is largely unexplored because it's not polished. And what I was talking about with AI, that the real skill of AI is like working out how to measure success and then learning how to adjust settings, ideally automatically, to maximize success. And that's the difference between programming and AI. So that's kind of what you're getting out of that project. Okay. So I actually have a lot more notes here for a lot more different types of project, but I realize that I'm horrendously going to run over time. So what I'm going to do is I'm going to jump to the key skills section and talk about that. And then next week, assuming this is what you want me to do, I will keep talking about more project types for another week. And that'll probably be enough time for me to like cover a few more diverse strategies that I use to identify projects that empirically across a number of years, a number of students has led to success for the students. That's kind of what I'm about, right? So I talked a little bit about these kind of what are the real skills you're hoping to learn. And I talked a little bit about with the first one, you're learning about how to be a heretic, how to challenge conventions, how to find like the softness in existing recipes and ways of doing things. And that's where innovation lies, basically. And you're also deeply and profoundly understanding how things work because you're sitting down with an AI and you're refusing to let it become the weird gatekeeping, like ritualized practice that a lot of these fields are, right? They are obnoxiously hard to understand. The people within them never communicate straightforwardly and intuitively, like I was talking about with the colored dots example. I'm always like, that's the level I want to be having the conversation with the AI at. I don't want you to tell me the special name that the community has taken to use this special thing. I want to know like in a sort of physical, intuitive sense, why is this working? Why does this help? You know, just make the AI make it make sense to you and you know challenge it and ask questions and just act like many quite young children do and have the bravery to just you know not not do the standard thing of like, oh, I know this clever thing. And by, you know, and I've sort of gathered this little cookie of cleverness that I'm going to repeat to other people so they know I'm clever. Like, you don't want to do that. You want to be like someone who takes complicated things and makes them like mundane and boring and, well, not boring, but like mundane and interpretable and takes all the magic out of it. Well, I don't think you take the magic out of it. I think what you do is you take the gatekeeping out of it, which I personally don't like. And that will give you the kind of intuitive understanding of things that will enable you to do something original, which the person who's just memorized a whole bunch of stuff, they can't do anything original because all they do is remember things and repeat them. Okay, so yeah, In terms of key skills, then, couple of key skills. First of all, is knowing how to construct AI projects. Ideally, I would heavily lean into synthetic data a lot of the time. Now, there can be problems with synthetic data, but the reason you're doing synthetic data is you want to remove the limitations of your project due to the data that you do have availability to. And the reason you want synthetic data is because you can get very precise measurements of how well your system is actually learning. When you have a small amount of data, you can easily convince yourself that you've made something good, but you don't really know because you don't have enough examples. So there's a thing in AI called overfitting, where you basically learn something that is really you're typically learning like the noise of the signal rather than the signal itself. And so whenever you give a new sample, you take your can recognizer or whatever and you take it into the real world, it just fails miserably because you learned the specific recognition of the cans based on the specific pictures that it was trained on and not the general concept of recognizing a can. So synthetic data can help you not make that mistake. So that's a good idea. The key thing I'll keep repeating pretty much every week is this idea that AI is different from programming. It's not about designing something in your mind. It's about measuring success and then searching for the best approach given the ability to measure success. And synthetic data makes that easier for you to do. So that's one of the key mental shifts associated with AI, and that's what you want to learn in your projects. Um, there's a whole bunch of other stuff. Some of it is relevant to projects I haven't talked about yet. There's lots to do with large language models and agent-based work and prompt engineering and stuff like that. But I will talk about all of that next week. So yeah, there's another couple of things which are useful I will talk about briefly. One I've mentioned, which is researching with AI. You want to get really used to this. Every time you go to do anything, even if you think you know it really well, go onto Gemini. I happen to pay for all the different AI models, so it's hard for me to tell what you can easily get for free. I think it's probably worth investing in at least one of the AIs with the like £20 a month subscription. If you can budget for that, that would be great. Um, and using their deep research and basically saying like, tell me everything that, give me a summary of everything that other people have done, which is similar to this task, right? Oh, Gemini Plus is free for students. Fantastic, right? So like, yeah, just every time you get to do something, you always do that. So what that means is that you never get into the nasty situation. Well, it can still happen, but it's less likely to happen where you work for ages on something and then you find other people have done it already. You want to be building on top of whatever the cutting edge is all the time, right? Tutorials and learning chronologically, that's for other people. If you're a Qlabber, then what you want to be doing is what is the best, coolest, fastest, most accurate thing in the whole world, and how can I make that better? And you go like, oh my God, that's impossibly hard. But like I said, smart people give up well before something is useful. They make something that is embryonically cool, but not generally useful. So you can be the person that makes something more useful, and then you can reap way more rewards than the academic did making that thing. Okay. So that's the researching bit. Now, the other bit, which is probably a whole week in itself, which maybe we'll do after next week or later on, is about programming with AI, which is something that I've been spending pretty much all my free time doing. And I have this totally crazy setup now. I have three IDs open at the same time. I'm doing three projects simultaneously. I'm not doing that literally right now. Obviously, you've got my full attention, but like it is crazy how productive you are. And the limitation that I have at the moment is effectively cost. So I run out of credits across these different IDEs, and that's the thing that's holding me back. I could probably do more than three projects at once if I had the money for it. So that is very cool and very exciting. And I think anyone who's in software development needs to, at some point, acquire that skill because, you know, I'm quite a fast programmer. I am a lot faster with three IDEs going at once. So just imagine the productivity gap that exists between someone who's doing that and a regular person or even a junior programmer, right? Like it's an astronomical difference. Now, having said that, and lots of people will say the same thing, it's easy for me to do that because I have literally decades of programming experience at a high level. So I don't need to acquire that foundation skill. And frankly, I don't know how best to handle that. My eldest son at the moment is kind of learning to program as well, and we're doing this fun little sort of choose your own adventure game where I've built the engine in JavaScript, and he is largely kind of creating content for it, but also writing a little bit of code that's like game code logic. And he's actually pushed back. He said, like, yeah, I don't want to touch the AI just yet. I want to be comfortable with the basics. And I think he's right about that. So the tricky thing is it's slightly incompatible with the Qlab approach. So the Qlab approach is like, wait, do the super advanced stuff. So that's something I think it needs a whole other talk, um, which is just about AI programming, when it's good, when it's bad, how to do it, all that kind of stuff. So later on, I'll do a whole thing on that. Okay, but that's definitely something you want to bear in mind or have in your roadmap to learn. Okay, cool. So what I'm going to do now is we're already over time. So the first question is, um, do you guys want me to keep talking? What I was going to do was respond to some of the questions, the QA questions, some of the ones that I can answer quickly, and then I was going to ramble on a bit more about the more epic questions for maybe another 20 minutes, 30 minutes, depending on time. So yeah, what do you think? Maybe if we make a break here at this point, and then anyone who's like, no, I this is this is enough. That's a bite-sized thing. You just feel free to go at any time. And the rest of you who might be enjoying this, I will keep rambling on for that. Okay, cool. Right. Let's have a quick okay, yeah, no worries, no worries, Zane. Feel free, head on. Yeah, I'm sure you have other things to do, and not everybody can just stay on a call and talk endlessly. Um, okay, brilliant, thank you. Right, so let me just check these. So what I'm going to do is just quickly look through the questions in the Slido stuff. Okay. Okay. What tools, platforms, frameworks do you think work well for project-based learning and AI, and how do you see them evolving? Um, I'm not a fan of frameworks. I will try not to spend too long on this. I learned how to be good at programming from computer game development. And game developers have a way of working. I tend to think of computer game development as like the Formula One of programming. So we're massively concerned with performance. We do lots of measurements on the way things should be done. I once remember somebody telling me that the way Formula One make their cars is they design their car, they build it, and then they just start drilling holes in it until it falls apart. And then they don't drill where it fell apart, and they just keep drilling holes in it to try to reduce the weight. And it's like it's not the way normal people would make a car, but it's the way you make something that runs really fast. So the thing I like about games is that games is very much like the philosophy I'm going to keep talking about over and over again, which is where you measure things. You know what good is, and you have a way of measuring good, and then you don't believe your stories. you try things and you measure them and you see whether they work well or not. And I think this is a good philosophy for everything. But whenever you look at platforms, frameworks, tools, um, that's sort of somebody trying to get you to buy into an ecosystem. And as a game developer, I'm like, I want the least amount of hidden complexity that I'm dependent on as possible. Which is why, like, for the machine learning thing that I was doing, it was all pure JavaScript, right? There was no PyTorch, there was no TensorFlow, there was nothing like that. It was just like, obviously that brings a whole load of constraints and problems with it, but it just meant that I didn't have to depend on anything. I could put breakpoints in everything. I could deeply understand everything. When I first started using Stable Diffusion, I did the same thing, right? Like I had the Stable Diffusion library, I made it run in an IDE, and I put a breakpoint and I just stepped through the code. And I was like, I want to know what every function does. And if the function does something that I don't think is useful, I'm going to literally rip it out of the code base until I've got this like Formula One car like result that is just the complexity that I need and nothing else. So I'm a bit of an extremist when it comes to that kind of thing. But maybe I'll talk more about that when we have the talk about AI programming, or just programming with an AI, basically. Um, can you elaborate more on the ML mindset? I will keep dropping hints to that, but I'm going to save that for the kind of big questions at the end. I'm definitely going to run out of time answering the questions, so I'm going to stick to the first two that were in the chat, or were in the Slido thing. So the first one was talking about the AI boom, that it's a bit like the dot-com boom. Is it going to crash? So it's the same thing that people say about any stock market crash, where they basically say that the price of the share value of things is disconnected from reality. And it is a little bit true, right? So the Stargate, the server farms that like Elon Musk is building, that Sam Altman's building, and things like that, these server farms are so massively expensive that you have to sell a huge amount of stuff to pay for them. Absolutely enormous amount of stuff. Stargate started out at like half a trillion, and it's looking to be, he's talking about perhaps multiple trillions going into Stargate. That is insane. That is, that's just so ridiculously large amount of money. Um, it's the total valuation of a leading tech company, one of the top five or something. So that's an insane level of investment. I don't know how it compares with something like the oil industry, but it's up there. So one of the things that happened, actually, I'm not sure where it occurred temporally. I think it was after the dot-com crash, actually. But like a huge number of broadband providers, they got masses of investment to lay copper cable, basically, and fiber optic cable to provide broadband infrastructure. And almost all of those businesses went bust. And they were then bought for like pennies on the dollar, basically. But that period of exuberance created a very expensive infrastructure investment that otherwise would have been impossible. So I think it is very possible that big AI companies could go the same way of broadband. Now, from a consumer perspective, you don't actually notice any difference at all, right? First, you get broadband subsidized by people with crazy venture capital pricing, and then you get broadband that's cheap because people have bought it cheap after it's gone bust. And the only people who've lost out were the investors. Okay, so in that situation, AI just continues, it's all grand, and that's the situation. The dot-com boom was a little bit different. That was where most of the businesses were new businesses venture funded businesses. And suddenly the venture money dried up very, very rapidly. And those businesses weren't profitable businesses. They were bankrolled through venture capital and they were just burning through cash and they went bust. And they were never really particularly viable businesses. Um, and so that had a big impact, and then that had a psychological impact on lots of things like hiring, students deciding to do computing, all kinds of stuff like that. So do I think that's going to happen with AI? Well, a lot of people will say, and I agree with it, that the circumstances are very different because the people who are pouring all that money and investment into AI, the primary people who are doing that are people who are companies that are massively rich. Even OpenAI is massively rich. And the reason they're massively rich is because they have a huge source of income. And, I know myself, right? Like I have used up a lot of my disposable income on AI credits, right? I spend $200 a month on Cursor. I'm now spending $100 a month on Claude Code, as well as other things as well, right? And that is a crazy amount of money, right? That is a crazily high amount of money. And nothing in my life um, has really, short of my children needing medical care or something, um, nothing in my life has like been a reasonable deal for spending that amount of money. And I'm not a company, and I know companies are spending a lot more. So I think there is a clear source of revenue, which means that it's unlikely to happen in exactly the same way. I could imagine that people will chill out a bit over the server farms at some point, or they'll find a cheaper way of doing it. And that could definitely change. But I think, generally speaking, it probably won't explode the way that the dot-com era did. Okay. And then the final thing, which is very indulgent, is the singularity. So I apologize for the other people who put in conversations about some questions about the NHS and frameworks and things. I will get to those next week. So instead, I'm just going to tell you a little bit about singularity. So for those of you that don't know, the singularity is the idea that if technology is improving at an exponential rate, and like I say, this Ray Kurzweil, I don't know exactly how to pronounce his name, but he wrote the book The Singularity is Near and really popularized the singularity in a lot of ways. He drew all these graphs in his book, which show like lots of these sort of S-curve shapes where something like grows in an exponential way and then levels off. And so a lot of people looking at things on a short time scale and a single technology would say that's the form that all innovation takes, this sort of slow ramp up, very rapid adoption, leveling off. Okay. One of the reasons for that actually is, I think, the reason that things form that S-curve shape is because of this thing I talked about before, which is sometimes called the trough of disillusionment, which is basically where you have a cool tech demo that isn't practically useful, and then you have this useful thing over here, and you're trying to get from one side to the other, right? So self-driving cars are, Elon Musk is, for example, desperately trying to push self-driving cars across to the other side. Elon Musk successfully made electric cars cross to the other side. So effectively a means of providing reliable, profitable income by turning something from a cool tech demo into something which has return on investment, right? The iPhone crossed the gap, and now Apple makes an ungodly large amount of money on iPhones, right? Something ridiculous like the price of an iPhone, what you pay is like double the cost of manufacture or something like that, which is a very high profit margin for a product. So right, so that's what we're trying to do, and what happens is that as you're observing things, you've got the tech demo, people making random things, and then companies start to get involved speculatively, and they sort of sell to early adopters and things like that. And they start to make it like tolerable for people who are happy to deal with a lot of errors, which is what like AI programming is like at the moment. Or self-driving cars are like that and stuff like that. And then but then it sort of gradually becomes more and more useful to people, and then it ramps up like this. And so as the number of users increase, which is just spreading out amongst the population, um, it rises up that very sharp bit, and then it starts to level off. So why does it level off? Well, it levels off because like most people who can afford iPhones have iPhones. Like most people who are going to be on Facebook are on Facebook, right? It starts to level off. And part of that is because it is now useful. And the product has reached this point where making it faster, maybe making it cheaper, but certainly adding more of whatever it is that's on that like exponential growth, making more of it do that doesn't seem to provide a return on investment, right? And we have very special, exceptional circumstances like chips, where chips kept getting faster, even though they did a perfectly good job at a certain point. And one of the reasons that chips kept getting faster was because chips were largely monopolized by Intel, and the founder of Intel, one of the two founders, was Gordon Moore. I think his name's Gordon, and he coined Moore's law, which said it was a law that chips got faster. And I briefly worked at Intel. I can tell you that Intel is a very authoritarian organization, and it is absolutely certain to me that the reason that we have exponential growth in the performance of computing is because a very powerful person wanted it to be the case. And which is a fascinating thing because almost every industry, they like that S curve like levels off because it's no longer like a profitable return on investment. Whereas Intel basically made it company policy that that was how they were going to work. And then they basically gave up a load of profits that they could have had by just chilling out with the same chip and just kept making it better and better and better. Right. Okay. So what is the singularity then? Well, the singularity is if you step back a little bit from these S curves, you see that as one thing starts to level off, there's a new S curve forms. And again, I always think about this in terms of an ecosystem. So there is a whole community of people that I'm definitely one of who are sort of early adopters. They are inspired and interested by novelty, and they have economic buying power. A lot of people who are early adopters are very rich. I'm not very rich, but like there are lots of people who are very rich and are early adopters. They tend to be like entrepreneurial types and things like that. So there's a huge amount of cash to be had with anything that is like that, right? Not to mention the fact that if you happen to be the business like Intel that manages to monopolize one of those S curves, you can go from being like someone like the founder of NVIDIA working at Denny's to being the CEO of one of the biggest companies in the world and well on track to become one of the richest people in the world, right? So it's an amazing like transformative thing. So like S curves, when they start to level off, new ones are formed. And there's a whole set of forces like venture capital, like disposable income, like psychological interest, like everything causing these new S curves to form. So when you plot all these S curves, they look like one big curve that never levels off. It just keeps going up. And so when you draw this, like eventually the curve seems to go crazily vertical. And when it goes crazily vertical, you can imagine time is just marching on. It's going to hit that crazy vertical, and then there's some point past that. And that's the point where you get like a new iPhone every day. And I don't mean a new iPhone, I mean the concept of the iPhone, a new revolution of that magnitude is occurring every day or every hour or every minute, right? Like that's what the singularity is. It's like an incomprehensible rate of advance that you think psychologically we couldn't possibly deal with, right? And I mentioned last week about AK, which is like this amazing guy who reviews all the coolest AI papers and then summarizes them. And if you just sit there and you try reading everything he posts, not even the source material, just literally the posts and clicking the link to just the picture and the paragraph summary of what the paper is about, you will experience like this overwhelming sense of technological progress, right? So we're already in like a pretty intense experience. And then a lot of people believe that that this will just go up, right? And the reason for this is that as these S curves have been happening, first of all, they've been happening faster, right? So OpenAI adoption is like if you look at all the top tech companies, the speed from like their first prototype to having like 1 million users or 100 million users has become narrower and narrower in time. So more and more products are passing through the S curve faster and faster. Um, and so it's very exciting. It's very exciting. And it looks like, maybe this is real. And the people who are leading the AI companies, they know all about the singularity, right? Singularity used to be this like fringy thing that people talked about, but it was definitely a fringy thing, and most people didn't consider it to be real. And but most of the leaders of tech companies will undoubtedly have something to say about the singularity, and most of them believe that it's real, and they're betting with massive amounts of money that this is the case. And what they're basically trying to bring about is what sometimes called a flywheel, which is a way of their organization operating, which means that as they operate, they go faster and faster and bigger, right? So the OpenAI flywheel is make cool things, get lots of people onto the platform, get a certain percentage of those people to pay money, use that money to make the platform cooler and bring more people onto the platform, right? That's a typical Silicon Valley startup phenomena, but they're doing it very, very well. And their total amount of money is going up and up and up. And then they can draw these like exponential curves of their revenue. And they can say, well, why don't you invest in us now for like many multiples of what our current revenue is? And then that will enable us to continue this upward curve. And if you invest now, you'll be able to sell your shares for a huge amount in the future. So that's a money exponential, which is likely to level off because, once where do you go from there, right? Like in 1 year, you're going from like $100 million server farm to a $1 trillion server farm. Like, are you going to go for a $10 trillion server farm after that? Like, we're talking about, the entire national debt of America or something. Like what, what? Like these are impossible numbers. There isn't enough cash in the entire world to pour into that, right? In order for that to happen, the whole world would have to get richer. Everyone would have to have so much more disposable income that they fully redirected into OpenAI and these other tech companies in order to pay for the server farms. So, okay, so there's definitely going to be an S curve of money, right? Unless we create some insane situation where everyone becomes massively richer. And that is what they believe will happen. At least maybe not everyone will be massively richer, but enough people will become massively richer that that money will be redirected back to them. But the bigger deal is actually that the cost of improving things will fall dramatically, which means their profits will rise dramatically, which means they can then afford the bigger server farm and they can just keep going to the moon, right? So how is the cost of what they do going to fall dramatically? Well, there's the software cost. So all the leading OpenAI companies, and I'd almost ruled Anthropic out of the race. They're a lesser known AI company, but the more I do AI programming, and I will talk all about AI programming in a couple of weeks, is the more I realize that they've actually got a very clever strategy that they may not even have been clever, but it's worked out really well for them. And I think it may continue to work well for them, even though they're definitely an underdog in the fight. Um, so what was I talking about? Oh, price. Yeah, yeah. So what they're all doing is they are focusing on AI programming. So the absolute cutting edge of AI in the world right now is AIs that program. Okay, so what's happening is if you think about how much training resource, compute time, effort, thought, everything is going into making these models better at programming. And then the IDEs that use these AIs are being designed to further build on top of that. So the IDE is providing tools and prompt engineering and all these other techniques to use the LLM AIs to do better programming. And that is the secret to the killer singularity in to some extent. Because basically, if they can get AIs to be superhumanly good at programming, which is something that everybody who's in computing should be paying attention to, then their costs are driven down. And basically, now they don't have to worry about hiring talent. And now they don't have to worry about like employing lots of people and difficulties with scaling, because they can have 1 million or 1 billion employees at the skill level of their best employees, making the software of their system better, right? And once they can do that, then they can go much, much faster than they're going. Like I'm operating at 3 times, if not more, speed by having 3 IDEs and 3 AIs programming for me. Imagine that scale was much, much larger than that, right? So that's a big one, but it levels off because there's only so many advances you can make by making your algorithm smarter. You still need like raw hardware and electricity and stuff like that. So there's a hard physical limit there. And that's why they're doubling down, not just in terms of server farms, but actually electricity production. So we're looking at Sam Altman has been quoted as saying things like 90% of all the electricity generation in the US is going to go towards AI. And in order to do that, they have to increase the electricity production in the US by a factor of 10 in order to do that, because they're not going to take any of the electricity away from the existing services, because they know that if they do that, they will get regulated and killed. So they mean building primarily nuclear power stations on a massive scale in order to generate the power to power the things. So, and it turns out like making nuclear power stations is like a bureaucratic nightmare, and it's slow and it's crap. In fact, it turns out server farms were like that. They took like multiple years to be built, and there was all these regulations and stuff like this. But it's amazing what money will do. Not just money, but money and status. So if you are facilitating OpenAI building their massive server farm, that's a nice story you can tell your folks and your friends. And it's a cool position to be in. And people will interview you on TV, and never underestimate the importance of status. So what's happening then is like server farms are becoming massively faster to make and massively better made than they used to be. They used to be a thing like, oh, it's this big approval process, everything was slow. Server farms are becoming like AWS, right? I need a computer, I just pay money, I get it immediately. The server farms are becoming that fast. Mark Zuckerberg is basically saying like, we're going to build server farms with tents. We're not even going to wait to build a physical structure. We're just going to grab stuff off the factory, ship it to a location, put a tent over it, and start it running, right? That level of speed. And that Silicon Valley, get it done, speed things up, factor of 10, factor of 100, Elon Musk kind of attitude, that is being applied to nuclear power stations as well as server farms. So effectively, most of the world, to a technology person, to a computing person, is like grossly inefficient, incredibly foot dragging. Like nobody in most industries is sitting there going, we've got to make it faster at all costs. What can we possibly do to make this faster and better? Right? Most industries are like, hi man, what do you want? Yeah, do you want this thing? Okay, cool. I'll be 3 weeks. That's what most businesses are like, right? But the Stargate project is like, what's the problem? Okay, we're going to literally commission some ex-military aircraft to fly some digging equipment from some other part of the world to start digging right this minute now. I want it now, right? And that is the difference, right? So where is this exponential curve coming from? It's coming from exponential money and that culture, that attitude, that like many people hate it, many people are intimidated by it, but like that is creating the curve. Okay, so let's say that continues going for like 5 years or something, and we get every year, every 6 months, we get like a 10x improvement in infrastructure investment, everything from AI. I don't even think that's a particularly controversial thing to say these days, which is insane, right? A 10x improvement in hardware, which will translate to a doubling in capability. It's something like that, right? So a lot of hand waving, right? It's hard to measure exactly what the real world impact of that will be. And I think the first killer app is going to be software. There's all these other businesses, people are trying to use AI for all these other purposes, but nothing has the like synergy alignment with what the people who are making the technology want built, like automation of programming. That is the thing. And automation of like innovative programming, research style programming. So that is just going to go really fast. So the question then is, can that be leveraged into other S curves that will keep that exponential growth going? And the big one, which is not too surprising to people, is things like robotics. So there are hard limits on how quickly you can put together a server farm, how big a factory you can create, how quickly you can build a factory where everybody is producing graphics cards, or how quickly you can mine resources out of the earth in order to, get them and to physically transport them around the world, right? Okay, great. No worries. Thanks for coming. So like, okay, are we going to do the transition, right? Are we going to be able to create enough nuclear power stations, enough compute, enough AI programming that we're going to solve all of those problems? There is a gap at the moment. If you make the AI really, really, really smart, it will make your robot more able to learn, and we've proved that. So that will solve a hell of a lot of problems. At the moment, AI for like mechanical engineering, CAD, electronic engineering, that is like virtually non-existent in comparison to AI for programming. But what I predict will happen is once the programming starts to like work and be, very highly automated, electronics and mechanical engineering and construction and everything, they are going to go the same thing. So all of this Silicon Valley can do spirit, money everywhere, all this kind of stuff, that is going to go into robotics and other engineering problems like how do you make nuclear power stations in a factory, right? How do you churn them out? Like the kind of things they make for nuclear subs, right? Which are just like these concrete capsule things that can never go critical because they're sufficiently small, but they generate a huge amount of power. And you just have this assembly line, like just churning them out, sending them to some tent somewhere in the desert, which is where Zuckerberg's server farms are, right? Whichever has the lowest regulatory requirements and enables them to operate in this way, which currently is Texas, right? So, like, are we going to connect the S curves together? And that's going to go. So we're going to have all of the obstacles as they arise. They are basically the leveling off and S curves. And these rich companies that with growing wealth and growing agency and power are going to leverage them to keep that curve going. And a lot of the leading tech people have said, often quite quietly, what's next, right? So, okay, so let's say it works, right? You got AIs that can do AI research. They can make AIs better from an algorithmic perspective. They can handle all the IT infrastructure for running a server farm and making it operate efficiently and stuff like that. All of that's made by the AIs, optimized like crazy, working out really well. All the chip design, all the layout of the circuits and everything on the boards, that's all done automatically. All the nuclear power stations and server farms, they are like maximally efficiently manufactured. We have a massive explosion in factories at strategic positions in the world, wherever is economic and regulatorily most convenient, and the same for shipping and infrastructure. And we're just like constantly building server farms bigger and faster and more powerful. And then we have robot manufacturing, and that's, gonna can it pass the trough, basically, where the robots can do maybe not quite as good as humans, but like good enough that it's practically beneficial to have the robot doing it. They're going to facilitate all of the physical work of like positioning the things, running the ships, and like getting the stuff into place and everything. And so you just got this like crazily fast growth, exponential growth of all of this infrastructure, all of this capability, robots that go faster, they move faster than humans do, that they are superhumanly dexterous, they have all these specialized attachments to do all these specialized things, that, they can work synchronously, they don't necessarily look like humans anymore, there's all kinds of specialized ones for specialized purposes, right? And it's just going like crazy. Right now, what happens with these tech booms is that you've got the like white hot line going up, and then the rest of the world is like, meh, I don't care, like this, right? And that's probably what it'll be like, right? Like for people paying attention, they'll be like, my God, you seen this thing used to be desert 2 months ago, and now it's like server farms for as far as the eye can see in every direction. They'll just take some bit of land nobody cares about and nobody minds, and they'll just build all this stuff in it like incredibly fast, right? And people are going, hey, isn't that cool the way isn't that interesting, whatever. But most people won't notice, because what the AI companies will not probably spend a lot of time doing is going, hey, industry that really is filled with regulation and gets in our way a lot, like, I don't know, medicine or law, which at the moment they're sort of playing with. But the reason they're playing with them is because there's still a practical income to be had from trying to get them as customers. And it's also a useful narrative about how AI is broadly useful. But when what I just described with the S curves is like, why would you bother trying to interact with something like the NHS when you could just go to some place in Texas with no regulations and build all these robot factories, right? That would feel so much, there would be so much more rapid progress. So the rest of the world will largely be unaffected until what will happen is one of these technologies that has crossed the trough of disillusionment will come and just start taking over. So it's like Uber with taxis. They're just going to come in, and functioning construction robots will come in, and they will just like, and then governments will introduce regulations and they'll try and slow it down. But like effectively, you've got this incredibly general, powerful, capable, working technology that's very broadly applicable, and it's going to sit there. And then there's going to be a business opportunity to just pick each industry in turn and be the person who like takes that business and does that version of it. So during the dot-com era, there was a similar idea, which was basically every company will become an internet company, and you could go into any industry. And if you became the internet company, you could unseat all the competitors and be the market leader by being the AI company. And I think exactly the same thing, assuming nothing goes wrong here, right? That same thing is probably going to happen. So you're going to have the people come in with the robots and the AI, and we're going to be the robot and the AI version of everything, farming, construction, like anything that can relatively trivially be translated. But that's still going to be going slower than like this crazy exponential curve that we've got with with the sort of AI self-improvement loop that's going like crazy like this, right? And And yeah, so that already is like an industrial revolution scale radical change to society, which could result in things like China becoming the most powerful country on earth, for example. They're well positioned to do that. All kinds of like radical shifts, right? The Industrial Revolution significantly unseated the power dynamics of the world. Something on that scale is enough to create like military scale tensions. There's all kinds of complicated things that might happen about where it would be best to sit while this crazy thing is happening, right? Now, this is assuming that everything that I've said will just play out the way that I've described it, which is not guaranteed at all. For those of you that have a sci-fi mindset, you may be curious to know what comes after the robots. What might be in the minds of the AI tech leaders as thinking what goes after that? Because you better believe they've thought about it, right? So my belief and what I would do if I was in their situation is that the next thing is biology. And there's already enormous investment in that. DeepMind are working on that. So the next radical technology, which is super embryonic, basically doesn't exist yet, is modifying cells to create kind of programmable matter. Basically, kind of the dream of nanotechnology, but something that like uses sunlight and resources from around it to grow and multiply and stuff like that. And, that is something that is more powerful than robots. It's more powerful than server farms. It's like a universal, manufacturable, computational raw material, right? And not only is it an incredible theoretical revolution in manufacturing and everything else, it's also the means to modify human beings, right? And so whether you're what's his name who runs Valve, whose name escapes me, or whether you're Elon Musk, or whether you're Demis Hassabis, or whatever, you have, or even Sam Altman, you have, Gabe Newell, thank you. You have invested in brain-machine interfaces because you know that once the AIs start running a lot faster than us, assuming that happens, um, and there's no reason to think they won't because we haven't seen any obvious roadblocks to improving AI performance, except for the fact that it takes exponential resources to double, which is a bit of a problem, I grant you. But is that we, in order to be vaguely relevant in this world, need to merge with the AIs. Now, obviously not everyone, because all of this will be going on in a world that seems largely the same to everybody else. They will just notice like Uber's come to town, the equivalent of Uber to coming to town with robots will happen. There'll be a little bit of tension, there'll be tension around that and stuff like that. But most people's lives will be just normal, right? But what people involved in this like crazy S curve are going to be doing is like they believe in something very different, a very different world, very different values, very different ideas. And the people, assuming all of this is correct and nothing gets in the way, and there's plenty of caveats to what I'm saying, but assuming this goes on, like the only way to stay relevant is to basically merge with the AI, which means one of two things. Either you somehow have this like biological part to you which is a historic legacy, which is your brain as it currently exists, attached to a supercomputer, and you've somehow managed to not just process the senses, but actually integrate the things. So it could be something like the same way your subconscious provides you with interesting ideas or things that you're compelled to do. It would be the same thing, except some kind of like super intelligent agent is providing that, right? So that's one solution. Another solution that's more radical is to actually completely scan the brain or partially scan the brain or do some kind of transition so that your sense of you becomes entirely in the machine. And then you don't have all the legacy problems of meat space, right? Which potentially could mean that you could be operating in a virtual environment in a server farm, operating at great speed, right? And by great speed, we mean like hundreds of thousands of times faster than real-time execution. Um, Obviously, that would be extremely expensive, even if it wasn't, didn't have all these technical obstacles and philosophical obstacles that people have. But let's say that you could pull that off, right? Which is not something that, if you get real neuroscientists and people who have expertise to bet real money and say, like, are you sure that uploads won't work? Like, are you sure? I've had these conversations. If I, they want it not to work. Lots of people want it not to work. But if it turns out that a copy of a brain running in a computer actually does the same thing, like who cares if it's got a soul or free will, right? Like for more practical purposes, this will be an entity that exists in the world that has agency and freedom and possibly even legal rights in some countries. And and it will be operating at like, many thousands times the speed. And in order to possibly tolerate that, because the rest of the world will be like in slow-mo, they will be in kind of virtual environments, doing things, designing stuff, interacting and being more on par with super capable AIs, right? So what's really fascinating about this is that if that is true, if that is how it goes, the speed of light starts to become a problem, right? So you will be sitting, you will be existing right beside the server farm because when you travel, although to us in real time we think of the speed of light across the earth. Oh, like I could be chatting to someone right now who's across the earth and in this call, and they wouldn't perceive it. But if we were running at like 100,000 times the speed, the latency would be appalling, right? So what was going to happen is people who are like this, whatever you want to call them, will become closer and closer to the server farms. And so you'll get these little places on Earth, which are like incredibly dense computational power, like barnacles on this big Earth. And everybody else can carry on with whatever the hell they want to do because there's no like S curve incentive to roll out the Terminators, right? It would be a weirdly indulgent thing to do. You're running at 100,000 times the speed of everyone else, which means that you experience 100,000 years in the space of 1 year in the real world. And you're going to spend that 100,000 years watching the world's slow motion extermination of humanity for negligible gain. Right? So what you need is you need a way to grow your computational and power resources geographically close to you at a phenomenally fast speed, because otherwise you just reversed the singularity for you. You slowed everything down crazily. You're now on the S curve. So as soon as everything gets faster, you get faster. So now radical innovation is now normal speed. Everything's now become normal for you. And the entirety of the Earth has become the way we feel about space. It's too far away. It's changing too slowly. It requires way too much resources to interact with. So you just got these like weird alien crystal-like structures growing in these deserts and relatively unpopular bits of the earth, just desperately trying to increase and improve and like gain an agency without physically moving very far because that's so slow to do, right? So that is like me cobbling together other people's ideas and my own, and this is like crazy. So yeah, I realize I have massively run over time. So I will wrap up with that crazy vision of how things might go. And yeah, please put in comments, questions, um, and uh, and I will elaborate more on what I think may or may not happen and why it might happen if that's what you want me to do. Particularly got a lot to talk about in terms of economics as well, and politics and how that might play out. Okay, so cool. All right, I will catch up with you all next week if you're about. All right, thank you very much.
Yes, thank you, John.
Thanks. See ya. Of course, my camera starts working now. All right, see ya.